Hey, 11s, we're now going to look at solving exponential equations now using logarithms. So previously, how we solve exponentials, we did solving by comparison. Here, now you can start doing the inverses. So if you've seen in my previous exercise on logarithms, it's exactly the same idea. Okay, so here we go. We've got 3 to the power of 2x minus 1 is equal to 28, right? Now, what's our problem? We don't want this exponential base 3. And we know that the opposite or the inverse of exponential base 3 is logarithmic base 3. So what I'm going to do here is I'm going to do log base 3 of the left-hand side, and I'm going to do the same for the right-hand side. We're just balancing the equation. I'm going to do log base 3 of the right-hand side. See that? And we know from our inverse operations, this line here where we're saying log base 3 of 3 to the power of 2x minus 1, whoops. We know that this line, these two are going to cancel out. We know that, okay? And that's what I was trying to show. Doesn't matter how you do it. I'm just going to clear this. I'm going to show it again. 3 to the power of x, right? If I did 3 to the power of log base 3, whoops, of x, the answer is still going to be x. I'm going to change that number to 7, okay? 3 to the power of log base 3 of 7, the exponential base 3 and the log base 3 are going to cancel out, so you end up with 7. But you can also do it the other way around. You could do log base 3 of 3 to the power of 7, right? And that's the same thing. Log base 3 and exponential base 3, they're inverses of one another. So those are going to cancel out and you're going to get 7 again. But be careful, you cannot do something like this. You cannot do 3 to the power of 2 times log base 3 of 7. Okay? So if you think it's going to cancel out 3 to the power of 2 times log base 3 of 7, the logs don't just cancel out like that. Technically, the answer is 49, but it's not 7. Okay, so you can't just cancel them out and do 2 times 7 is 14. You see, it's 49. The reason why is because you can't just inverse. I know I've tangent off a bit here, but it's very key for you to understand if you're watching this video here. It's very key for you to understand that the 3 and log 3 don't cancel out. That's what students do, and they do 2 times 7 and they say the answer is 14. You can't, okay? When you have this problem, you need to move the 2. Using rule number 3, we can bring the 2 to the top, and this becomes 3 log base 3 of 7 squared. Now you can cancel this out because it's 3 to the power of log base 3. That's when these two cancel out. But if you have something in between it, that doesn't cancel out. It's like saying 5 times 2, and normally if you say divided by 2, these two cancel out. But what if you then said take away 2 divided by 2? You can't then say these two take away and then 5 take away 2 is 3. We know the answer is going to be wrong. Okay? That's why you can't do that. That's the reasoning. Okay? So it's the same thing here. You need to make sure that there's no numbers in between. So I hope I make that very clear on what we're doing. So going back here, once you've done the inverse of you did log base 3 on both sides, they cancel out, and then what are you left with now? You've got 2x minus 1 on the left-hand side, and on the right-hand side, you've got log base 3 of 28. We don't know what that answer is. Leave it as an exact value, okay? Add 1 on both sides, so 2x equals to log base 3 of 28 plus 1. So I'm just going to write here plus 1, so just balancing the equation. And then over here, I'm going to divide 2 on both sides. So you got to divide every term. And so now x is equal to half of log base 3, 28 plus half. Okay, so that's your exact value without any change in your exponential equations. Okay, so make sure to understand what I was trying to say at the very start there about inverse operations. The reason why students find this tricky is because they're not doing balancing the equation method. They're doing some sort of changing formula. Don't do that. Stick to the basics on what you've learnt in year 7. You learned how to balance the equation through inverse operations, and you do exactly the same with logarithmic and exponential equations.